just a second, folks. Change clothes. Happens when you walk to the lab. Alright. Okay. Probably see my reflection. I'm putting on my attire. What you're looking at is that is the tip, one of the sides of the hematometer. That's kind of a, I guess you call it, reference point. If I'll show you the grid in a second. No, Xavier, I took it at the other. I took both classes actually at the other community college I was at. I hear there's a really good physics program here, from what I'm told. So let me show you all the grid. Here's the grid. There's a center, bunch of hash marks. Yep, there we go. That's the center of the grid. And so on the top left over here, there's some checkerboard boxes where cells reside. There are none. This is dirty, so what y'all seeing is just debris from it sitting in here, and of course some microscopic organisms that need to be cleaned off. But yeah, this section right here is the grid, and where we count the cells. And there's just like looks just like a checkerboard. That's the middle, and go back down here to our reference point. A little neat. This little thing down here is reference point. That's not what it's called. That's what I referred to it as. But that's where you actually inject your cells, and then through capillary action, the cells get dispersed over that checkerboard, and then to other four quadrants. There's a glass cover slip that goes over top of that assists with the capillary action. So what I'm going to do is get my stuff on, and we're going to take a look at some of these plates. I'm the only one here today. No one wants to come in on Fridays. Alright, I need to label these actually. Think about it. See which plate the best. Alright, let's look at this one. Yep, I did not label them. Okay. Let's get this over here. Okay, take these off for now. Now I gotta find them. My objective's all right, but it's way too close. This is the fun part. Oh, maybe it's too far away. I see something. There we go. We have adhesion. That looks terrible. Yes, Old B Jack, and I've not been on G Plus in a while. Thank you for reminding me, Fiona. If there is a benefit out for Jade, please link it 50,000 times, and I will definitely make a video about that. Oh, here we go. That is a terrible image. Let me fix that. So right now I'm in, this is a phase contrast microscope. Actually, can you all see that? Oh man, that's really bad. bit better, but yeah, you can probably see. There we go. It's not too bad. Not too bad. Let me this. You see a really good one down the bottom left there. And actually, if you look up here, those are some good ones. Let me pull that down so you guys can see. Check that out. That one, this one's adhered pretty well. You can actually, you almost see the nucleus. Actually, it might be multinucleated. Some of them actually end up doing that. There's a these are an immortalized cell line, and what ended up happening is that a company took an adenovirus, they chopped it up, and then there's a section of that adenovirus that has attached itself, I guess you could say, to P53. The P53 gene in the human genome helps prevent cancer. It's an oncogene, and so it's a tumor suppressor gene. Excuse me. So what ends up doing it tells the cell, hey, if you're messed up, you need to go pop. And if you take that off, well, the cells will just keep growing and growing and growing. Well, when you start messing with stuff in the genome, other things can go awry, and then what can happen is during cell division, well, they won't actually divide. Like they'll replicate their genetic material. They'll swell. They'll go really, really, really big, and you'll see multiple nuclei in there. This one, I'm trying to clean it up to see. It might just be a weird, like, elongated one, but it may be multinucleated. But actually, it's a little bit too early to tell. I'm not going to say that it is when it's still kind of early. There's another one over here on the left that you can, let me see if I can turn it a little bit. There we go. That's a nice big one. It's not as clear as this one, though. Yeah, that's a decent one. What I'm looking for is the amount of confluency, because they're still kind of just here and there. They're proliferating pretty well, but not as well as I'd love. Yeah, see that? Yeah, see that shiny one right there that you see in the top left? This one's not even adhered. Like, it's just kind of sitting there. So I'm guessing it's still working on creating that extracellular matrix. So if I had to guess, I'm probably at maybe around 10 or 15% confluency. I got some pretty good ones, but geez, like this, it's not, it's not anywhere near what I'm looking for. Like, yeah, I'm still seeing quite a few that haven't completely adhered just yet. Yeah, I'm in the lab. Yes. Oh, shit, damn it. Yep, that one hasn't adhered yet. You can tell. I mean, you see the brightness of it? That's kind of an indicator that it hasn't actually adhered. It still looks kind of round. This one's starting to. It's starting to kind of take on that elongated shape, but it hasn't actually adhered to the surface yet. So let me look around a little bit more. Ooh, wow, this nice clump here. Look at that. There we go. Look at that. Yeah, you see that one at the bottom there still kind of floating around. Even when I move this, look, watch. You see the other ones haven't even budged? Yeah. The other ones are still just kind of sitting there. Oh, they're starting to clump up too. Look at that. There we go. Oh, they've been dividing. Look at that. Let me clean that up for you. Yeah, these have been dividing. Huh. And actually, if we sit here and look at it long enough, we'll actually see them divide. It takes quite a while. I'm trying to find one that's in the midst of dividing, but I might be out of luck. Actually, you know what? This little one down here might be. He's moving around. I need a time lapse on this thing. Let me see if I can mess with the gamma a little bit. distinct color. Yeah, so basically, I started off with a handful of cells, and it's oh, actually, I think this one is dividing. Oh shit, I think we caught one. I thought it was just me moving. No, it's dividing. It's about to bud. Fuck yeah. No, where's it? No. Shit. I'm looking at the screen because it's easier to see. I'm not looking at the microscope. Damn it. I want to go back and find it. I think because I saw it, I think it was dividing. I was hoping to catch one. Let's see. So yeah, these in order for your cells to in order for you to get more cells, the way that you get them is from other cells that already exist. Well, how does one become two? Well, you split one in half. And so what you end up doing is you get a nice, healthy, ripe cell. It replicates the stuff that's inside of it. It just copies everything. Then it splits off, and you have two smaller cells. Then they grow to their appropriate sizes, and then they split. So that's ideally what you see happening. I'm gently moving the tissue culture dish. I'm trying to find one that's actively dividing. No, I'm not growing skin right now. I will be growing skin in the fall. But this is the class that is going to basically teach me how to do it. Right now, these are kidney cells that are growing. These are floating around, but I'm not sure if they're dividing. There's a few of them. Yeah, you could tell. You see how they're bright right here? That brightness tells me that they've not adhered to the surface yet. You can compare them to these cells here. These cells are much more mature. They're settled. Like I can move this dish anywhere, and they're going to stay there because they're actually stuck there. This one, however, is not. So fresh cells are rounded up like that. So I'm hoping if I watch long enough, I'll see one divide. I'm going to try and get a finer picture. It's hard to get it. Let me focus in on this one right here that's rounded up. You know, look on YouTube all you want. This takes skill. And that's why I'm the only one in the lab on a Friday, because I'm trying to gain the skill. This is going to be the bread and butter of what I do. Then I need to actually have some dedication and not just watch YouTube videos. Yep, Fiona's right. The fun thing that we're going to do with these is we're going to trick them into growing more by giving them more room to move around. Eventually, these are going to become so aberrant that they're not going to care. They're just going to grow anyway. We might get lucky and see it dividing. Sing to him. Please grow any light, become oblong and beautiful. Please give me something to record in my laboratory notebook. I'm not going to quit my day job. Come on. I know it takes half an hour for them to divide, but geez, show me something. Evidently, I'm supposed to be able to see the chromatin. There's a point where I can see. I think it's during anaphase. No. It's during metaphase. Yeah. So during metaphase, I'm supposed to be able to see the chromatin, and then especially like I think things get active, like really really active during anaphase, and that's another indicator. Do I have to bring my broken guitar and my Pikachu suit? Come on. So chromatin is your DNA with your histones and other associated proteins. You could think of it just like a bundle of DNA and associated proteins. So it's not the chromosomes that look like X's and whatnot. That's what the chromatin will form into. So while it's kind of like a jumbled mess, you could think of it as chromatin. That helps. Oh my goodness. No, they're probably just, I guess they might be just making their extracellular matrix. This one is nice and rounded. I like the shape on this one, but it's probably going to start creating that extracellular matrix and then start to look like these over in the back here. These, let me change the focus. Whoops, wrong way. So gotta catch it just right. Okay, so you see here how like they have like this weird like polygon shape here. These are mature cells. Like these are cells. This is what this wants to be, but they have an extracellular matrix that you can't really see because it's underneath it. You could kind of see like some fuzzy stuff on the sides of here. That's basically what's laminin and other proteins that they're using to stick. Jesus. All right, so this is trying to excrete those proteins for it to sit on, and then once it can adhere to those proteins and their products, you will get them elongating and looking like this. But I'm just going to go ahead and let me start up here, go across. Some thrash metal, yeah. Could do that. Oh, this is a nice bunch. Look at this. Check this out. Oh, that's sexy. Yeah. I like. Very nice. How much? Huh? I saw that. No. I saw you move. I saw you move. What's that you got there? Damn, it's hard to get this thing. Okay. Oh, they're separating. Oh, shit. They're separating. Oh, look at it. Look at it. They're separating. Watch. Watch, I just saw it yank. I don't know why we're whispering. Okay, come on. I'm pretty patient, but I just, or maybe it was just me moving it. Maybe that's what it was. I see this little one here just kind of moving around, doing something. Not as bright as the others. It'd be messed up if I was watching yeast grow. That'd be messed up. Like, oh, this is so cool. Yeah, that was yeast. Oh, great. That's awesome. All right, throw that plate away. Actually, speaking of which, let me look at this refrigerator. Because let me check on my media. I'm going to need a few days. Everybody Everybody else's media is in here. Oops. And let's see. Oh, my Kool-Aid still looks good, folks. Kool-Aid still looks good. For our returning mature cell, we've already done that. They're called induced pluripotent stem cells. We're already doing that, good sir. Now, doing it well is another question, because you have to consider tumorigenicity. When you start manipulating, because what ends up happening is that we can take certain we take chunks of viruses. We cut up their genetic material, and we let them do what they do, and they inject what we want into the cells, and they'll become immortalized cells, or they'll like this one. But sometimes they'll become induced pluripotent stem cells, and the induced part is what we do, that injection. So they'll turn back to what they were previously, and then we can give them certain growth factors. We can put them in a particular environment and trigger them to turn into something else. Like let's say if there's a woman that is suffering from breast cancer, and we want to put more breast tissue back in her, we could take some epithelial skin cells, epithelial tissue, and then program them to turn into breast tissue. It's actually really, we actually spoke about this. There is if you put certain stem cells in a media with it's lactose something, basically breast milk, not breast milk, mammary glands. If you put them near tissue with mammary glands, they will form in the shape of a dome, like shape of a breast. That triggers them. So it's funny what we can do, but yeah, like Sam says, there's risks involved with that. That's why embryonic stem cells are some of the best ones around. And that's what I have here. These are human embryonic kidney cells. Okay. This plate is pretty good, but it's not that great. And what I'm looking for is confluency. And I think I showed you guys a picture of what I mean. Hold on, I'll find it. Here we go. So, let me hold that back. So you see what I'm looking at here? From what I can tell, I'm probably somewhere around 10%. I want to be around 40 before I even think about trying to split some of this. So I'm not anywhere near where I need to be. Which is whatever, but okay, well, I'm getting some now. I gotta change the focus again. Jesus. Ooh, those are some good ones. I like that. Look at that. Yep. Oh, you can actually, I don't know if you guys can see it. You see the fuzziness around here? You can probably barely see the fuzziness. That's the extracellular matrix. And I think some of them are called micropilli. How long does it take? These have been here for a few days. We actually have to calculate that. That's our next assignment. We have to do what's called a growth curve. And so once we get to about 40% confluency, we're going to start taking some measurements by using a hemocytometer. That little device I showed at the beginning. Here, I'll show it to you again. So we're going to be using this object here underneath the microscope to count how many cells we have using. I'm sorry, you have to use math. I'm going to say this for the people in the back who are watching and say anything in the chat. You have to use math in order to figure out your growth curve, and you have to use what is that stuff called? God damn it, semi-log paper to actually graph it. So you actually have to know what the fuck you're doing, because if you don't, you're gonna have a bad time. Yeah, yes, semi-log paper. That's what it's called. I could remember. Yeah, the math's not that hard. The math's not that hard. It's just knowing what you're working with, knowing the volumes. Why not? Because we're dirty, wet lab bench scientists. That's why. That's why we don't use R. Because we're dirty, wet lab scientists. We have bioinformaticians for that. Oh. Somebody said, what are we supposed to use to graph this? What if we can't draw? So what can we use programs? I said, yeah, Python. No, nobody said shit. I was like, yeah, we can use Python. Not a word. 15 people in the room plus the instructor. Just complete silence after that. Yeah, that's what I get. It's not too bad though. I'll probably get 15% confluency probably by tonight. Man, look at god damn it. Come on. There we go. That's oh, you can see a very defined nucleus. Look right here. Look right here. Look right there. Look at that shit. That's what I'm talking about. Look at this is a oh man, let me get a picture of that. Picture this shit. It's a preview. Where is I'm using a program here called Infinity Capture. It's working with the Olympus CK2. Oh, now my antenna's quartz. I don't know what the fuck that is. All right, let me take a picture of this. I'm gonna come back tomorrow and take a look, because I gotta get with a classmate from my calculus class. We're gonna go over some homework. Again, you have to actually, be doing shit. Lab 2, day 3. Oh no, it's day 2. I'm sorry. Or where is it? Shit. Might be important. All right, I'm going to label these plates. 1, 2, 3, and 4. All right. I'm probably going to wake up hella early tomorrow and just come in and play around with this. So I was supposed to be checking confluency and all the plates, and I was like, nope, let me just look at them. I'm just gonna look at them. I will email my professor and told him I got carried away looking at my plates. I'm pretty sure I will be punished thoroughly, or he's gonna say, yeah, I kind of expected that. So stay right there, folks. All right. Shut all this off. Back on. Turn my hoods off. This is the oven, the incubator. There, people kept I don't know why people decided they wanted to put 1, 2, 3, 4. They stack. Just put them on top of each other. Think about that damn room. The hell does it look like, a bakery? Do that shit. There we go. Door closed. What is it? 20? Nope. Come on. So I'm making sure that CO2 is at 5%. temperature is going back up to 37 Celsius. So, all right, America. All right, so I'm going to, oh, check this out. Fiona, do you recognize the thing? Check this out. I have never seen it in my life. It has a CRT monitor. Look at that shit. I am told that they don't even make those anymore. That's how ancient this thing is. That's crazy. I was like, how do you get your hands on something like that? Why? Why? An Olympus view. It just has a bunch of syllables. I don't know. Oh man. And watch this. I'll turn it on. You hear that? I just turned it on. Still no light. Like, why waste money on this? Come on, man. This light still doesn't come on. Ain't my money. What am I? I'm just a lowly undergrad. But I gotta talk to our TA. He's working at Baylor University, working on male contraception, working with gonad tissues and shit. So some high speed shit. So so I need to make sure I have things turned off. Let me see the tanks. Let me look at that. Okay, tanks are good. I turned the UV lamp off on that hood. Computer's off. Dust shield is on. I got the keys. I just need to turn the light off. Okay. I want to leave stuff like I found it, not like some assholes. I guarantee if I go back here, there's gonna be gloves in this damn bag. Oh, nope. They proved me wrong. Nope. They didn't put the gloves in there. Let me check over here. We just got scolded for this shit. Oh, no, they stopped doing it. Yeah, okay. All right, I like it. Yeah, you would think adults would figure that shit out, but... No, turn off the light. Boop. So let me lock this up. I forgot which key. Yep, here it is. Come on. There we go. Oh my god. Hold on. Okay. There we go. Oh shit, I just realized. Look at this. Genomics Research Lab. Look at that. Oh, Polymeric Materials Research Lab. Oh, look at that. I wonder what else is around here. Ah. It's probably going to go out. Probably going to go out. Go down the stairs. Gotta return these keys. Well, folks, that's it anyway. I thought I was gonna have more time, but no. Let's save this weekend for the wife. Try to pack up all my stuff. Let's see, man. Yeah, crack house. Be more familiar with that. Let's see. Savage. We'll return this. Go play some Pokemon Go with the wife this weekend. Oh, damn. Oh, well, yeah. On the other side. Okay. I'm surprised my signal's still holding up. Not as good as Ronnie. Never as good as Ronnie. I'm working diligently every day to try and meet that standard. I'm trying. Awesome folks and the kids. All right.